Hello everyone. In this video, I'm going to talk about exponential functions and how to solve more specifically word problems that involve exponential functions. Okay. So who uses this? Scientists model populations with exponential functions. For example, here we have a table. The table and the graph show an insect population that increases over time. So notice at the beginning, there were 2 insects. After 1 day, there's 6. After 2 days, there's 18. After 3 days, there's 54. Every day, the previous number is being multiplied by 3. 2 times 3 is 6. Times 3 is 18. Times 3 is 54. So this constant multiplication becomes what defines an exponential function. And if I graph these numbers, like we see here on the right, we get that smooth curve that keeps going up forever, which is what we've been practicing over the last week. Now, for this specific function, if the equation is going to be f of x is equal to 2 times 3 to the x power. Okay, and each part of this equation has a special function. Okay, notice that this 2 here is the starting value. This 2, the starting value up here. This 3 is the multiplier. So this 3 represents these 3's over here. And finally, the variable, the x, this is going to represent um, the, the time. In this case, is measured in days. And every time we change the x value, it'll give us a different value. And we could use the calculator here to find the next number. So using the pattern, on the 4th day, it would be 54 times 3, which is 162. Or if I plug in 4 into the function, it would be 2 times 4, 2 times 3 to the power of 4, which is 162. Okay, so that's a quick explanation of exponential functions. Here we have the general formula. So f of x is equal to a times b to the power of x, where a cannot be 0 because if a was 0, then everything would be 0, so it wouldn't be a function anymore. And then b cannot be 1 because 1 to any power is always going to be 1. And b has to be greater than 0, so it has to be a positive number. So, but basically, the important part is this part, f of x is equal to a times b to the power of x. And like I said above, this is the starting value, and this is going to be the multiplier. Now let's go into some word problems. So the function f of x is equal to 2 times 3 to the x power models an insect population after x days. What would be the population on the 5th day? So word problems, you have to read them very carefully to extract their important information. Okay, X represents the number of days. And the question is, what would be the population on the fifth day? So that means that X is going to equal to 5. So we're going to substitute that value into the function to get our answer. So f of 5 is 2 times 3 to the fifth power. And I have my calculator here handy. So 2, oops, so let's do a new line here. 2 parentheses 3 close parenthesis. Here's the exponent button to the power of 5. And that's going to be 486. Okay. And then to answer this, I'm going to answer this in a complete sentence. Okay. On the fifth day, the population will be 486 insects. Let's do another example. The function f of x equals 1500 times 0.995 to the power of x, where x is the time in years, models a prairie dog population. How many prairie dogs will there be in 8 years? So again, identify what the x represents, time in years, and we want to answer the question, how many prairie dogs are there in 8 years? So we're going to substitute the number 8 into the function. So f of 8 is equal to 1500 times 0.995 to the power of 8. So now I'm going to use my calculator. 1500 parenthesis 0.995 close parenthesis to the power of 8. Okay, and this is going to give us 1441.039565. I just wrote the whole number, but we're talking about number of dogs here. So we cannot have 0.039565 of a dog. So we're just going to round to 1441. So after 8 years, there will be 1441 prairie dogs. All right, let's do another example. The function f of x equals to 8 times 0.75 to the power of x models the width of a photograph in inches after it has been reduced by 25% x times. What is the width of the photograph after it had been reduced 3 times? So x is reduced by 25% x times, and we want to find out what is the width of the photograph after it's been reduced 3 times. So x is equal to 3 for this function. So f of 3, 8 times 0.75 to the power of 3. Back to my calculator. 8 times 0.75 to the power of 3. And that's going to be 3.375. Okay. So the width of the photograph after it has been reduced 3 times is 3.375, and the units that we're looking for is inches. Okay, notice since I'm talking about a measurement here, I went ahead and wrote all the decimal points. Okay, if we measure something, it's common to have decimals. Different from the previous when we're talking about number of dogs. All right, let's do, I think, one more. Yeah, this is the last one. In the year 2000, the world population was about 6 billion and was growing by 1.21% each year. At this rate, the function f of x is equal to 6 times 1.0121 to the power of x gives the population in billions x years after 2000. Using this model, in about what year does the population reach 7 billion? So this problem is a little different because, okay, let's identify x years after the year 2000. What we want to find is the year when the population reaches 7 billion. But they didn't give us an x value to substitute in. So we're going to guess and check until we find a number that crosses 7 billion. So first, let's type in the function into the calculator here. 6, oops, let's go to a new line, hit enter to go to a new line. 6 times 1.0121, close parenthesis, to the power of, so let's say if I if I press 1, it's 6.07. That's too low. I want it to be over 7. 2, 6.14. Let me jump to go faster. 6.29, no. 644, no. I'm getting closer. 6.6, no. To the power of 10, no. To the power of 12, closer. Let me go to 13. There we go. So if 12 is the exponent, it's below 7. If 13 is the exponent, finally we cross 7 billion. So let's go back to the question. Using this model, in about what year does the population reach 7 billion? Well, it's going to reach it after 7 years. This problem started in the year 2000. So 7 years after the year 2000, I'm sorry, 13 years after the year 2000 is when the population will reach 7 billion. So just write that down. Population reached 7 billion in the year 2013. And below this, I'm just going to write the work. F of 13 is equal to 6 times 1.0121 to the power of 13 is 7.015. Okay. And that's it.